Did you know that the spacesuits astronauts wore on the moon over 50 years ago offered less flexibility than the average winter coat? This brings us to a fascinating evolution. Imagine a future where spacesuits are not just protective garb, but sophisticated marvels of technology, thanks to the extraordinary potential of nanotechnology. It's a future where these suits could vastly enhance human capabilities, fundamentally changing the way we explore and survive in space. With nanotechnology, the very fabric of spacesuits could become lighter, more resilient, and even adaptive, improving safety and efficiency in ways we can barely begin to imagine. So, how exactly could these tiny wonders revolutionize the suits of tomorrow? Join us as we dive into the remarkable intersection of space exploration and nanotechnology. We'll uncover how these innovations might transform space suit design, enhancing flexibility, safety, and functionality, and what that means for the future of human space travel. Throughout the history of space exploration, spacesuits have been an essential, albeit cumbersome, piece of the puzzle. Let's take a journey back to the early days of space travel. The first spacesuits, developed in the early 1960s for missions such as Mercury and Gemini, were essentially modified high-altitude aviation suits. They were heavily insulated to protect astronauts from the extreme temperatures of space, but this came with significant drawbacks. These suits were rigid, bulky, and provided limited mobility, making tasks outside the spacecraft particularly challenging. As we progressed into the Apollo era, the design of spacesuits had to adapt to the demands of moon landings. The Apollo suits offered more flexibility compared to their predecessors, featuring a jointed, multi-layer approach to withstand the harsh lunar environment. Despite these improvements, astronauts still faced considerable difficulties. The suits were heavy, making movement laborious, and the restrictive nature meant that even simple tasks like picking up a rock required significant effort. This limitation underscored the urgent need for ongoing innovation in suit design. Moving into the era of the Space Shuttle and the International Space Station, spacesuits evolved once more. The Extravehicular Mobility Unit, or EMU, was a significant leap forward. It introduced modular construction, allowing parts of the suit to be swapped out for different missions, and incorporated life support systems directly into the design. While these advancements represented a step forward, astronauts still experienced the constraints of weight and limited dexterity, impacting their ability to perform complex tasks in microgravity. Throughout the decades, one common challenge persisted: achieving a balance between protection and mobility. Traditional materials used in spacesuits provided necessary protection from radiation, micrometeoroids, and temperature extremes, yet they inherently restricted the range of motion and comfort of the wearer. This perpetual trade-off highlighted an essential question: how could we design a suit that offers maximum protection without compromising flexibility and function? Enter nanotechnology. As we stand on the brink of a new era in space exploration, nanotechnology promises to revolutionize the very fabric of spacesuit design. Imagine materials engineered at the molecular level to create fabrics that are not only lighter and stronger than ever before, but also capable of dynamic adjustments to environmental conditions. These advancements could lead to suits that are as flexible as the human body, enhancing astronauts' ability to conduct intricate tasks with ease. Nanomaterials could provide unprecedented insulation properties without adding bulk, creating a climate-controlled suit that adapts to the body's requirements and external conditions. Furthermore, the integration of nanosensors could offer real-time health monitoring and environmental analysis, directly addressing astronaut safety and well-being. With nanotechnology, spacesuits are poised to become more than just protective coverings. They could evolve into sophisticated personal systems that enhance human capability and endurance in the extreme environments of space. This sets the stage for our next discussion, where we will explore specific innovations nanotechnology brings to the table, promising to redefine the boundaries of what is possible in space exploration. So, how exactly will these modern solutions materialize in future spacesuits? Stay with us as we delve deeper into this exciting frontier. To truly appreciate how nanotechnology can reshape the future of spacesuits, we first need to understand what nanotechnology is. At its core, nanotechnology involves the manipulation of matter at the nanometer scale, which is about 1/1000th of a meter. This is the realm of individual atoms and molecules where the physical properties of materials can behave in unexpectedly powerful ways. Imagine being able to construct materials atom by atom, allowing scientists to tailor properties like strength, flexibility, and conductivity to an unprecedented degree. This might sound like the stuff of science fiction, but nanotechnology is actually all around us. You might not realize it, but nanoparticles are already in many everyday products. For instance, they are used in sunscreens for their ability to provide stronger UV protection without leaving a white residue. Nanotechnology is also at play in the fabric of stain-resistant clothes and in the tiny particles that help make scratch-resistant coatings for eyeglasses. These consumer products leverage the unique properties of nanomaterials, offering us a glimpse of their potential on a much larger stage, space exploration. One of the most captivating aspects of nanomaterials is their exceptional strength-to-weight ratio. Take, for example, carbon nanotubes. Despite being incredibly lightweight, these cylindrical structures are stronger than steel and highly flexible. This makes them ideal candidates for enhancing the durability and flexibility of spacesuits. By incorporating such materials, future spacesuits could be both lighter and more resilient, reducing the physical burden on astronauts while also providing superior protection against the harsh conditions of space. Flexibility is another key area where nanotechnology shines. Traditional materials can be rigid and uncomfortable, but materials designed at the nanoscale can exhibit remarkable levels of elasticity without sacrificing strength. This could lead to suits that move more naturally with the human body, allowing astronauts to perform complex tasks with greater ease and precision. Imagine a suit that adapts to its wearer, offering an almost second skin experience. This is what nanotechnology could ultimately deliver. To underscore the transformative potential of nanotechnology in this field, let's consider the views of experts. Dr. Michaela Ferkel, a leading figure in nanotechnology research, explains, "The capability to manipulate materials at the molecular level means we can create more sophisticated and functional materials that can transform how we approach design challenges." Her insights exemplify why nanotechnology is seen as a game-changer in diverse fields, not least in the realm of space exploration. These advancements are not just theoretical possibilities. Scientists and engineers are actively working to integrate nanotechnology into the next generation of spacesuits. Potential applications include nanoscale sensors embedded into the suit fabric to monitor vital signs and environmental conditions, enhancing astronaut safety. Additionally, nanocoatings could provide enhanced protection against the microscopic debris that constantly bombards space travelers. As we stand on the cusp of this cutting-edge revolution, the integration of nanotechnology into spacesuits represents a significant leap forward. These breakthroughs promise to redefine our approach to human space exploration, enabling longer missions and deeper forays into the cosmos with greater safety and efficiency. In our next segment, we'll delve into specific innovations and applications of nanotechnology in spacesuit design, exploring how these incredible materials could pave the way for the next era of interstellar travel. Imagine the possibilities as we harness the power of the nanoscale to push the boundaries of human exploration beyond what was once thought possible. Stay tuned to discover more about how these advancements might soon become a reality. As we venture further into the application of nanotechnology in space suit design, let's dive into one of its most promising aspects: enhanced durability. Imagine fabrics that can withstand the severe conditions of space, where temperatures can swing dramatically from blistering heat to freezing cold, and where radiation exposure is a constant threat. Nanotechnology is paving the way for fabrics that not only endure these extremes, but also provide protection far superior to anything currently available. The key lies in the incorporation of nanoparticles into the very fibers of the suit. This begins with understanding the unique properties of nanoparticles, which include increased tensile strength and thermal stability. For instance, by embedding materials like carbon nanotubes or graphene into the fabric, scientists can create a composite material that is incredibly strong yet remains lightweight. These materials are engineered at the molecular level to offer resilience against the thermal extremes encountered in space. Graphene, in particular, has shown outstanding heat resistance, making it ideal for suits that need to protect astronauts from both solar radiation and frigid shadowed areas. But it's not just about withstanding temperature. Nanoparticles can also play a critical role in radiation protection. Outer space is flooded with high-energy particles from the sun and cosmic rays, posing serious health risks to astronauts. Nanomaterials such as boron-based compounds can be integrated into spacesuit fabrics. Boron is known for its neutron absorption capabilities, which could translate into better shielding from radiation, thus reducing the risk of radiation sickness or long-term health impacts for astronauts. Researchers are already experimenting with such protective measures, and while full-scale integration into spacesuits is still in the experimental phase, the progress is promising. Current experiments and prototypes are already showcasing these possibilities. For example, NASA and various research institutions are actively investigating flexible radiation shields composed of nanocomposite materials, which could be applied to spacesuits. By tuning the composition and structure of these materials at the nanoscale, they aim to create lightweight but highly durable layers that offer a robust defense against the harsh space environment. One intriguing development is the use of self-healing nanomaterials. Imagine a spacesuit that can repair itself when punctured by micrometeoroids. Certain polymers embedded with nanocapsules could autonomously seal breaches, ensuring that astronauts remain safe from potential catastrophic exposure to space's vacuum. These innovations are not just theoretical. Prototypes are currently being tested to assess their viability in real-world conditions. As we consider these advancements, it's important to reflect on their implications for long-term space missions. Enhanced durability could significantly extend mission durations by reducing the need for frequent suit repairs or replacements. Astronauts might venture deeper into space with greater confidence, knowing their suits provide formidable protection against the unknown variables of the cosmos. This increased durability also lays the groundwork for other improvements, such as comfort and mobility, which we will explore next. How might advances in material science further enhance the experience of astronauts, allowing them more freedom to move and enabling longer extravehicular activities without fatigue? As we continue, consider how these leaps in durability could fundamentally reshape human space exploration, ushering in a new era where longer, more ambitious missions become not just feasible but routine. Stay tuned as we delve into the exciting prospects of improved comfort and mobility made possible by nanotechnology. Imagine being an astronaut trying to carry out tasks in a spacesuit that's as stiff as cardboard. Every movement is a struggle, and even the simplest actions require considerable effort. This has been a reality for astronauts for decades, but thanks to nanotechnology, a more comfortable and mobile future in space is on the horizon. By revolutionizing the materials used in spacesuits, nanotechnology promises to make them lighter, more flexible, and better molded to the human form, creating an experience akin to wearing a second skin rather than donning an unwieldy armor. One of the most exciting prospects is the integration of nanoscale sensors into the fabric of spacesuits. These tiny sensors can be embedded within the materials to continuously monitor and adapt to the wearer's movements. Imagine a suit that automatically adjusts its fit in real time as an astronaut bends, stretches, or crouches. This kind of adaptability could drastically reduce the physical strain associated with wearing spacesuits, allowing astronauts to focus more on their tasks and less on fighting their attire. To illustrate this, consider the advances currently explored in smart textiles. Researchers are developing fabrics woven with conductive threads that can sense pressure and movement. These textiles can provide feedback to systems embedded in the suit, making micro-adjustments that enhance comfort and flexibility. This technology is already being tested in terrestrial applications such as athletic wear and medical garments, which hints at its potential for space exploration. As these materials evolve, they offer a glimpse of how astronauts might soon experience unprecedented freedom of movement and comfort. Real-life prototypes are bringing these concepts closer to reality. The European Space Agency, for instance, has been experimenting with materials that incorporate smart fibers, allowing for increased flexibility and comfort. Meanwhile, ongoing collaborations between NASA and innovative startups aim to refine these technologies, ensuring that the next generation of spacesuits is not only protective but also as comfortable as possible. The voices of those who stand to benefit from these innovations, the astronauts themselves, provide compelling endorsements. Veteran astronaut Chris Hadfield notes that comfort is critical when you're operating in space because it directly affects your effectiveness and safety. Hadfield's experiences underline the importance of designing suits that mitigate fatigue and stress during long missions. Industry pioneers, too, are optimistic about these advancements. Dr. Robert Hoyt, a leader in space materials research, states, "The integration of nanotechnology into spacesuits can profoundly change how we approach long-term missions, offering not just protection, but an environment that adapts to the astronaut." His insights capture the transformative potential of these innovations, emphasizing a future where spacesuits are both adaptable and integral to enhancing human capabilities in space. Moreover, the improvements in comfort and mobility set the stage for broader applications, such as environmental adaptability. Future spacesuits might not only adjust to movements but also to changing external conditions, adapting their insulation based on temperature fluctuations or altering their stiffness in response to varying atmospheric pressures. This level of adaptability could be crucial for missions to places with unpredictable climates, such as Mars or even the icy moons of Jupiter. In the next phase of our exploration, we will discuss how the integration of these technologies could influence suit adaptability to different environments, paving the way for missions to new and challenging destinations. As we continue, consider how enhanced comfort and mobility could transform the astronaut experience, making space more accessible and missions more efficient. Stay tuned as we delve into environmental adaptability, the next frontier in space suit innovation, where nanotechnology continues to push the boundaries of what's possible. Imagine stepping onto the surface of Mars, where the sun's rays are scorching during the day, but as night falls, temperatures plummet to freezing levels. This drastic shift would be a challenge for any traditional spacesuit. However, nanotechnology offers a groundbreaking solution to this problem by enabling spacesuits to adapt dynamically to changing environmental conditions. Let's explore how these adaptable suits can not only protect astronauts, but also enhance their efficiency during missions on diverse celestial terrains. At the heart of this adaptability are nanomaterials that can regulate temperature, much like how a chameleon changes its color to blend into its surroundings. These materials have the ability to alter their properties in response to environmental cues. For example, some nanoparticles can respond to temperature changes by expanding or contracting, which can help regulate heat within the suit. Picture these nanoparticles acting like tiny thermostats embedded in the fabric, opening to release heat when it's too warm and closing to retain warmth when it's cold. This would allow astronauts to remain comfortable regardless of the temperature swings they encounter. Another fascinating aspect of nanotechnology is its potential to enable color changing or camouflage capabilities. This could be achieved with materials that contain chromogenic compounds, which change color when exposed to certain stimuli, such as light or electrical signals. Imagine a spacesuit that adjusts its color to blend in with the reddish-brown hues of Mars or the stark white and gray of a lunar landscape. This feature could be particularly beneficial in research missions, allowing astronauts to study the terrain without disturbing the ecosystem. It could also offer tactical advantages by reducing visibility during sensitive operations. The benefits of these adaptive features are manifold. Beyond comfort, temperature regulation could significantly reduce the energy required to maintain life support systems, freeing up resources for other mission-critical tasks. Improved camouflage capabilities could also pave the way for more in-depth studies of celestial environments, where minimizing human impact is crucial. To further highlight the potential of these innovations, let's draw a simple analogy. Consider a house equipped with smart technology that adjusts lighting, heating, and security based on the time of day and occupancy. Just like this smart home, a nanotechnology-enhanced spacesuit monitors the astronaut's environment and optimizes conditions, allowing them to focus on their mission rather than on discomfort or dangers posed by the external environment. Moreover, this environmental adaptability naturally leads us to consider other enhancements, such as health monitoring and safety. By integrating nanosensors into spacesuits, astronauts' vital signs can be continuously monitored, ensuring timely alerts to any potential health issues. These nanosensors can detect changes in heart rate, hydration levels, and even exposure to harmful radiation, providing a comprehensive picture of the astronaut's health and safety status. Incorporating nanotechnology into spacesuit design doesn't just address immediate physical needs. It fundamentally enhances the safety and well-being of astronauts during their missions. By making these suits intelligent and responsive, we take a significant step towards creating a more sustainable presence in space, where humans can operate efficiently and safely amidst the vast and varied environments of our solar system. In our upcoming discussion, we'll explore how these advancements in adaptability and health monitoring might reshape our approach to long-term space habitation. We'll delve into the broader implications for maintaining astronaut health and safety on extended missions, paving the way for future explorations into the unknown. Stay tuned as we uncover more about how these innovations are laying the groundwork for humanity's next giant leap into the cosmos. As we step deeper into the fascinating potential of nanotechnology in spacesuits, integrating health monitoring systems emerges as a transformative advancement. Picture this, a spacesuit that not only shields astronauts from the harshness of space, but also acts as a guardian of their health. This is no longer a far-fetched idea, but a rapidly approaching reality, thanks to the integration of nanosensors into spacesuit design. Nanosensors, tiny devices capable of detecting and responding to physical stimuli, are at the forefront of this innovation. These sensors, when woven into the fabric of spacesuits, can continuously monitor an astronaut's vital signs, including heart rate, respiration, body temperature, and hydration levels. Imagine the peace of mind this brings, knowing that these essential health metrics are under constant surveillance, reducing the chances of undetected health anomalies during missions. But the potential of nanosensors extends beyond just tracking vital signs. Consider the environmental hazards that astronauts face in space. From radiation exposure to harmful gases, the threats are numerous and varied. Nanosensors can detect these hazards in real time, alerting astronauts to changes in their immediate surroundings that could compromise their safety. For instance, should radiation levels spike unexpectedly, these sensors could trigger alerts, allowing the crew to take immediate protective actions. Communication is another significant benefit of nanosensor integration. The data collected by these sensors can be transmitted in real time to mission control centers on Earth, allowing medical teams to monitor astronauts' health and environmental conditions from afar. This enables timely interventions should they be necessary and provides crucial data to inform decisions about mission safety and success. In discussing these advancements, we find insights from experts particularly illuminating. Dr. Lisa Murphy, a lead researcher in space health technology, emphasizes that the ability to monitor astronaut health and respond swiftly to environmental changes is a game changer. It enhances crew safety and could be critical to the success of long-duration missions. Her perspective highlights how health monitoring is not merely an added feature, but a pivotal aspect of mission planning and execution. These innovations in health monitoring provoke important questions about the future of space exploration. How might these capabilities change our approach to crewed missions to Mars or beyond? Could we see a future where the risks associated with long-term space travel are significantly mitigated? The answers could redefine space mission protocols and open up new possibilities for exploration. Furthermore, as we anticipate the integration of these systems, we must consider the implications for energy efficiency. With a suit that actively monitors health and environment, energy consumption becomes a critical factor. The balance between maintaining continuous monitoring and conserving power is essential to the success of extended missions. In our next discussion, we'll delve into how nanotechnology not only aids in health monitoring but also enhances energy efficiency, ensuring that future spacesuits are not only smart and safe but also sustainable. We'll explore innovative approaches to managing energy consumption and how these practices could further bolster mission success in the unyielding environment of space. As we wrap up our look at health monitoring, consider the groundbreaking steps we are taking, steps that could propel us into a new era of safer, more efficient space travel. Stay tuned as we continue to explore the exciting frontier of energy efficiency in spacesuit technology. Energy efficiency is a cornerstone of successful space exploration, especially as missions become longer and more demanding. Imagine the possibilities if spacesuits could not only protect and monitor astronauts, but also generate and efficiently manage their own power. Thanks to nanotechnology, this is more than just a futuristic concept. It is becoming an attainable reality that promises to revolutionize how we approach energy use in space. A major facet of this transformation is the development of nanoscale solar cells. Unlike traditional solar panels, which can be bulky and less efficient in harnessing sunlight, nanoscale solar cells can be integrated directly into the fabric of spacesuits. Their small size and flexibility allow them to cover larger surface areas without adding extra weight or bulk, which is crucial for maintaining the mobility of astronauts. These cells can efficiently convert solar energy into power, continuously charging the suit's systems whenever the sun's rays are available. This means that energy can be harvested directly from the environment, minimizing the need to carry heavy batteries and reducing the overall payload of missions. Imagine a scenario where an astronaut suit is powered by the very sunlight that surrounds them, effectively turning each spacesuit into a small, self-sustaining power plant. This capability is particularly promising for missions on the Moon or Mars, where access to direct sunlight can be abundant. The flexibility of nanoscale solar cells allows them to maintain high efficiency even when partially shaded, which is often the case in the varied terrains of extraterrestrial landscapes. Beyond solar energy, nanotechnology also introduces materials capable of harvesting energy from the wearer's movements or temperature differences between the body and the surrounding environment. These energy-harvesting materials, often referred to as piezoelectric or thermoelectric materials, generate electricity from mechanical stress or thermal gradients. By integrating these materials into a spacesuit, astronauts could generate power simply by moving or through the natural heat of their bodies. This represents a groundbreaking step toward creating suits that are less reliant on external power sources, significantly enhancing mission sustainability. Let's look at some current research that points toward these exciting advancements. Researchers at institutions like the Massachusetts Institute of Technology are exploring the use of graphene-based materials to create highly efficient and flexible solar cells. Graphene's unique properties, such as its conductivity and strength, make it an ideal candidate for this application. Similarly, the European Union's graphene flagship project is investigating thermoelectric materials that can convert body heat into usable energy, providing a constant source of power that complements solar-derived energy. The implications of these energy-efficient solutions are profound. They not only reduce the dependency on weighty power storage systems, but also enable the extension of mission durations. As energy management becomes more sophisticated, astronauts can stay in space longer without frequent resupply missions, thus paving the way for deeper exploration of our solar system. Enhanced energy solutions supported by nanotechnology allow for more extensive scientific endeavors as well. With reliable power, astronauts can operate more energy-intensive equipment, conduct comprehensive research, and remain focused on their tasks without the looming concern of energy shortages. This kind of innovation is crucial as we set our sights on ambitious projects such as establishing lunar bases or conducting manned missions to Mars. In our continuing exploration of the potential of nanotechnology in spacesuit design, we will next consider how the culmination of these advancements sets the stage for future space exploration. Stay with us as we delve into the broader implications of these technological breakthroughs and how they might lead to the sustainable exploration of new frontiers. As we examine the real-life applications and prototypes currently utilizing nanotechnology in spacesuit design, we uncover a world where science fiction meets reality. Several projects underway are not only pushing the boundaries of what's possible, but also giving us tangible glimpses into the future of space exploration. One such initiative is the collaboration between NASA and various academic institutions focused on developing the next-generation spacesuits known as the XEMU, the Exploration Extravehicular Mobility Unit. These suits are being crafted with cutting-edge nanomaterials to enhance durability and flexibility, incorporating features like nanoscale coatings for improved abrasion resistance and flexibility. Through partnerships with universities like the Massachusetts Institute of Technology, NASA is exploring the integration of smart textiles embedded with nanosensors. These sensors are designed to continuously monitor astronauts' vitals and environmental conditions, offering crucial data that can improve safety and mission outcomes. Another promising collaboration involves the European Space Agency (ESA), which is working with several innovative startups and academic partners to develop suits with advanced nanotechnology capabilities. For instance, the ESA has been testing nanomaterial-based thermal control systems that can dynamically adapt to the harsh temperature variations in space environments. These prototypes highlight the potential of using nanotechnology not only to improve comfort and safety, but also to enhance the energy efficiency of the suit by reducing reliance on traditional heating and cooling systems. Meanwhile, universities around the world are playing a pivotal role in advancing spacesuit technologies. The Delft University of Technology in the Netherlands is researching the use of graphene and carbon nanotubes in energy storage solutions embedded within suit fabrics. Their work aims to create a suit that can harness and store solar energy more efficiently, providing consistent power without adding significant weight or bulk. This type of innovation is essential for enabling longer duration missions where resupply options are limited. In the private sector, companies like SpaceX and Boeing are closely monitoring these developments, considering how they might integrate such advanced materials into their suits for future private space travel initiatives. The vision is clear: to enable astronauts, whether government-affiliated or private citizens, to venture further and stay longer in space with enhanced safety and efficiency. These collaborations and prototypes illustrate both the promise and progress being made in the realm of nanotechnology-enhanced spacesuits. However, a natural question arises: when might we see these suits in mainstream use? The timeline for adoption depends on the success of ongoing testing and the ability to bring these innovations to production scale. Although significant advancements have been made, challenges such as cost, manufacturing scalability, and rigorous testing for safety and reliability remain. Yet, as we look toward the future, the potential seems boundless. Imagine a time when astronauts travel to Mars in suits that are not only protective but also smart, sustainably powered, and adaptable to the conditions they encounter. This vision is driving current research and development efforts, with the hope of seeing these technologies fully realized within the next decade. As we stand on the cusp of a new era in space exploration, these real-life applications and prototypes offer more than just a promise of things to come. They represent the concerted efforts of scientists, engineers, and visionaries working together to turn the dream of advanced space travel into reality. In our next segment, we'll explore these futuristic visions in more detail. How might these innovations redefine humanity's relationship with space? Join us as we continue this thrilling journey into the frontier of space exploration. Navigating the integration of nanotechnology into spacesuits involves facing a series of technical and ethical challenges that are as complex as they are essential to resolve. While the potential benefits are immense, several considerations must be addressed to ensure that this revolutionary technology can be safely and efficiently implemented. Let's delve into these challenges and explore expert insights on how they might be overcome. One of the foremost challenges is the manufacturing cost associated with nano-engineered materials. The intricate processes involved in designing and producing nanomaterials mean they can be significantly more expensive than traditional components. Scaling up production to create large enough quantities for spacesuits without compromising quality or consistency adds another layer of complexity. As Dr. Emily Chen, a materials scientist from Stanford University, notes, the promise of nanotechnology is clear, but we must innovate manufacturing techniques to make these advanced materials economically viable for large-scale production. This observation underscores the need for continued investment in research and development to streamline production methods and reduce costs. Beyond costs, long-term health impacts represent a significant concern. Given their minute size, nanoparticles can interact with biological systems in unpredictable ways. As they are integrated into wearable technology like spacesuits, ensuring that these particles do not pose health risks to astronauts is paramount. Rigorous testing and long-term studies are required to understand potential effects fully, and developing reliable containment strategies within the materials is essential to prevent unintentional exposure. This is where regulatory standards play a crucial role. Organizations like the European Space Agency and NASA are working closely with health and safety boards to develop comprehensive guidelines that ensure the safe use of nanomaterials in space exploration equipment. Regulatory frameworks need to evolve alongside these technological advancements. John Reynolds, a policy expert at the International Space Agency, points out, as we push the boundaries of what's possible with nanotechnology, regulation must keep pace to ensure that innovation doesn't outstrip our ability to manage risks. Establishing international standards for nanotechnology applications in spacesuits is essential to foster innovation while maintaining safety and public trust. Ethical considerations also arise when deploying nanotechnology in space exploration. The potential for dual-use applications, where technology developed for peaceful purposes might be adapted for military uses, necessitates careful oversight. It's crucial to develop and adhere to ethical guidelines that govern the use of advanced technologies in space to ensure they contribute positively to human advancement. Looking ahead, experts are optimistic that these challenges can be surmounted. Innovations in material science and production techniques continue to emerge, driven by the collective efforts of scientists, engineers, and policymakers. Collaborative initiatives such as international research consortia and public-private partnerships are key to advancing this field. As we envision the future of spacesuits enhanced by nanotechnology, it's essential to consider both the incredible potential and the obstacles that lie ahead. Imagine a world where astronauts don suits as advanced as the technology that propels them into the cosmos, equipped with the resilience and adaptability needed for extended missions to Mars and beyond. However, bringing this vision to life requires meticulous planning, rigorous safety standards, and collaborative global efforts. In our next segment, we'll explore this envisioned future in greater detail, considering how overcoming these hurdles could lead to not only new frontiers in space, but also innovations that impact life on Earth. We'll delve into how the solutions devised for these challenges could ripple across industries, sparking advances far beyond the realm of space exploration. Stay tuned as we continue this exciting journey into the possibilities that await. Imagine a world where space travel is as routine as boarding an airplane, where interplanetary voyages are simply part of human life, and where the colonization of other celestial bodies is not just a distant dream but an attainable reality. This is the future we are on the brink of creating, powered by the growing potential of nanotechnology-enhanced spacesuits. These suits, replete with advanced materials and adaptive designs, promise to unlock new realms of exploration and discovery, reshaping our understanding of the cosmos and our place within it. Nanotechnology at the core of spacesuit design could be the key to unlocking interplanetary travel. With suits that can withstand the rigors of space for extended periods, astronauts may soon embark on missions to Mars and beyond, venturing into territories once thought unreachable. The ability to generate and efficiently manage power through nanoscale solar cells and energy harvesting technologies will enable longer, more sustainable missions. Imagine exploring the icy moons of Jupiter or the vast plains of Mars with suits that not only protect but enhance human ability, adapting instantly to extreme environments and providing real-time health monitoring and environmental assessments. The idea of extraterrestrial colonization becomes more plausible as these advancements take root. With durable, flexible, and self-sustaining suits, humans could establish bases on the Moon, using them as stepping stones to further voyages. These bases could serve as research hubs where scientists study the effects of low gravity on human physiology or test new technologies essential for life in space. Nanotechnology could also facilitate the creation of habitats that protect against radiation and temperature extremes, possibly using local materials for construction, thereby promoting sustainability and reducing the need for Earth-based resupply missions. Thought leaders in the space industry echo this visionary outlook. Elon Musk, a well-known proponent of space colonization, often emphasizes that making life multiplanetary is a safeguard for the future of humanity. His words reflect the urgency and excitement surrounding these advances. Moreover, futurist Michio Kaku envisions that nanotechnology holds the promise of transforming space suits into intelligent platforms that think, adapt, and evolve. These views underscore the transformative potential of nanotechnology in enabling a future where space exploration reaches unprecedented heights. These breakthroughs do more than push technological boundaries, they inspire. By making the seemingly impossible attainable, they ignite a passion for space exploration in the hearts of young minds around the world. The promise of exploring new worlds supported by cutting-edge technology could motivate a new generation of scientists, engineers, and explorers. Children growing up today might dream not only of becoming astronauts, but also of designing the technologies that make deep space exploration possible. As we reflect on the significance of these advancements, it's clear that nanotechnology in spacesuits represents more than just technological innovation. It symbolizes humanity's unyielding spirit of exploration and our drive to understand and inhabit the cosmos. These developments challenge us to rethink our capabilities and to dare to dream bigger, pushing the boundaries of what it means to be human in an ever-expanding universe. In conclusion, as we stand on the threshold of this new era, it is vital to recognize the profound impact these advancements will have not only on space exploration but also on our global society. They hold the potential to foster international collaboration, drive technological innovation across industries, and catalyze a deeper understanding and appreciation of our place in the universe. By embracing the challenges and opportunities presented by nanotechnology, we are not just advancing technology, we are paving the way for humankind's next giant leap into the stars. As we draw our exploration to a close, let's take a moment to reflect on the transformative potential of nanotechnology in revolutionizing spacesuits. Throughout our journey, we've uncovered how these tiny marvels promise to alter the very fabric of space exploration, ushering in a new era where astronauts are equipped with suits that do more than protect, they empower. We've seen how nanomaterials can make spacesuits lighter and stronger, allowing for greater flexibility and durability. Imagine a suit that acts as an adaptive second skin, naturally moving with the astronaut and offering unrivaled protection against the harsh conditions of space. Consider the potential for energy autonomy, where nanoscale solar cells and energy harvesting technologies provide a self-sustaining power source. This innovation could dramatically extend mission durations and distances, enabling humans to explore the solar system more freely. The integration of nanosensors for real-time health monitoring and environmental assessment ensures that astronauts have immediate access to vital information, enhancing their safety and effectiveness on missions. These groundbreaking advancements are not just incremental improvements, they represent a quantum leap in how we approach human space exploration. By embedding intelligence into spacesuits, we transform them from passive barriers to active participants in the exploration narrative. This shift opens up new possibilities for missions to Mars, the Moon, and beyond, making them not only feasible but profoundly enriched by the capabilities these technologies offer. Let us not forget the impact these innovations have on our broader vision for humanity's future in space. As we contemplate establishing permanent bases on the Moon or venturing to the icy moons of Jupiter, nanotechnology-enhanced spacesuits will be pivotal. They hold the promise of making extraterrestrial habitats safer and more sustainable, setting the stage for a future where humans live and work across the solar system. It's clear that these advancements are not only technological but also cultural. They inspire a new generation of dreamers, thinkers, and doers who will rewrite the rules of space exploration. As astronaut Chris Hadfield once said, "To me, it's the most natural thing in the world to fly in space. We're explorers." His words capture the essence of why we continue to push these boundaries, to explore, discover, and understand our universe and our place within it. As we conclude, reflect on the immense possibilities that lie ahead. Consider how these innovations could redefine our collective future, both in space and here on Earth. We invite you to share your thoughts and join the conversation. What do you think the next giant leap will be? How might these technologies change our world? If this exploration of nanotechnology in spacesuits has sparked your curiosity, be sure to subscribe for more insights into futuristic technologies. Together, let's continue to explore, innovate, and dream about the incredible future that awaits us. Thank you for joining us on this journey, and we look forward to venturing into new frontiers with you.